A plus B equal to ABC, B plus C equal to ABC, and C plus A equal to ABC. How do we find the value of A, B, and C? First, let us call this equation 1 and equation 2 and this equation 3. The first thing we are going to do is to subtract equation 2 from equation 1. That is equation 1 minus equation 2. The left hand side of equation 1 is A plus B. So we have A plus B minus the left hand side of equation 2, B plus C equal to ABC minus ABC, ABC minus ABC. This means that A plus B minus times B, that is minus B, minus times plus, that is minus C, equal to ABC minus ABC, that is 0. Let's proceed further. Clearly, B minus B, that is 0. We are left with A minus C equal to 0. This means that A is equal to C. Take note of this guy. The second thing we are going to do is to subtract equation 3 from equation 2. Doing that, we have equation 2 minus equation 3. So we're going to have B plus C minus the left hand side of equation 3, C plus A. C plus A equal to ABC minus ABC. This means that B plus C minus times C, that is minus C, minus times plus, that is minus A, equal to ABC minus ABC, that is 0. Let's proceed further. This means that we have B, C minus C, that goes. We are left with minus A equal to 0. Clearly, B is equal to A, which also means that A is equal to B. Take note of this guy. Now, since A is equal to C, and here we have A equal to B. From these two conditions, A equals to C and A equals to B, this means that B is equal to C. Take note of this. Also, it is very obvious that we can combine these three conditions, that is, A is equal to B and B is equals to C. Take note of this, very, very important. Now, from equation 1, what is equation 1? Let me show you equation 1. Equation 1 is A plus B equal to ABC. A plus B equal to ABC. What we have to do now is to write this equation in terms of A. So we fix A. A plus, what is B? B is equals to A, equal to A times, what is B? B is equals to A times, what is C also? C is equals to A. This means that A plus A, that is 2A, equal to A times A times A, that is A cube. So we have A cube. If we move 2A to the right hand side, that is minus 2A equal to 0. Let's continue. What do you notice here? You will notice that A is common. We can factor it out. So we have A into A squared minus 2 equal to 0. This means that A is either equal to 0 or A squared minus 2 is equal to 0. Clearly, A equal to 0 is one solution. Consider this guy also. A squared is equal to 2 by moving minus 2 to the right hand side. If we take the positive square root of both sides, that will be square root of A squared equal to plus or minus square root of 2. This bigger square root takes care of this power. We have a equal to plus or minus root 2. This means that a is either equal to root 2 or a is equal to negative root 2. These are the other values for a. A equals to root 2 and a equals to negative root 2. So, since a is equal to b equal to c, that is when a, b, and c are the same. So, for the first solution, a is equals to 0. So, that will be a equal to b equal to c equal to 0. This is one solution. The second solution will be a equal to b equal to c equal to, when a is equals to root 2, the values of b also must be root 2 and the value of c root 2. So we have root 2. Also, for the third solution, that will be a equal to b equal to c equal to negative root 2. We can also rewrite all these guys in a more unique way. Consider this first. We can rewrite it as 0, comma 0, comma 0. That is a is 0, b is 0, c is 0. And this also, that will be root 2, comma root 2, comma root 2. And this guy, that will be negative root 2, comma negative root 2, comma minus root 2, just in a coordinate form. This is the required solution for this nice algebraic problem. That's it. Thanks for watching. Watch the next video up here.